Section 5.2, Compound Interest. In a standard bank account, any interest we earn is automatically added to our balance, and we earn interest on that interest in future years. This reinvestment of interest is called compounding. For example, you invest $10,000 in the account that pays 3% interest compound annually for 5 years. I started with $10,000 in the account, and that account pays me 3% interest compound annually for 5 years. What does compound annually means? It means that every year, the amount of interest that I earned from the previous year will be added to my principal, and I will start earning interest for that amount of interest that I earned from the previous year. Let's take a look in this table. And here I have year 1, 2, 3, 4, and 5. My principal that is corresponding to each year, and also the interest that I earn each year. For the first year, my principal is $10,000. The interest that I earned during the first year is 3% of $10,000, which is 0.03 times 10,000, which is $300. So if I leave my $10,000 here for 1 year, I earn $300 in interest. Now, because this account is compound annually, starting on the second year, my $300 interest that I earned from the first year will be added to $10,000. So the principal on my second year will no longer be $10,000. It will be $10,000 plus $300. So my new principal is $10,300. And the interest for the second year will be based on this new principal, $10,300. So on the second year, I'll still earn 3% interest, but 3% interest of $10,300. And that is $309. So you see that I started earning interest for the $300, which is the interest that I earned from the first year. Now, on the third year, the principal will be the principal from the second year added to the interest that I earned from the second year. So it will be $10,300 plus $309. And that is $10,609. And on the third year, I'll earn the 3% interest of $10,609. So I take 0.03 times 10,609. That is $318.27. The amount of interest that I earned during the third year is $318.27. Now the principal for my fourth year will be $10,609 plus $318.27. So the principal of my fourth year is $10,927.27, and the interest that I'll earn in the fourth year will be 3% of $10,927.27. So which is 0.03 times 10,927.27. 0.03 times 10,927.27. So I get 327.8181, but this is in the amount of dollars, so I'm going to round it to the nearest cents, which is rounding to 2 decimal places, which is 327.82. The principal for my 5th year will be 10,927.27 plus 327.82, which is 11,255.09. And the interest for the 5th year will be 0.03 times $11,255.09. So 0.03 times 11255.09. And that is 337.6527. I'm rounding it to 2 decimal places, so it's $337.65. The reason why I rounded to 2 decimal places, because this is in dollars. When we work with dollars, we are allowed to have 2 decimal places. So these are the amount of interest that I earn each year during these 5 years. The total interest will be the sum of 300 plus 309 plus 318.27 plus 327.82 plus 337.65. So that is $1,592.74. And the total amount that I have in the account after 5 years will be $10,000 plus $1,592.74, which is $11,592.74. In this example, we only invested $10,000 for 5 years. So it's very easy to have a table for 5 years. But imagine if this is 25 or 50 years, we don't have enough time or space to have a table for 25 years or 50 years. So we need a formula for compound interest. So the formula of compound interest is A equals P times 1 plus R over N raised to N times T. A is the total balance in the account after T years. P is the principal or the starting balance, where T is the number of years we plan to leave the money in the account. R is the annual interest rate, which is APR. N is the number of compounding periods in 1 year. For example, if the compounding is done annually, how many times in a year if it's done annually? It's once a year. So N is 1. If the compounding is done quarterly, how many times in a year if it's done quarterly? It's 4 times. So N is 4. If the compounding is done monthly, how many times is done in a year? If it's monthly, it's 12. So N is 12. So this number N is the number of compounding periods in 1 year. Example, if you invest $3,000 in an investment account paying 3% interest compounded quarterly, how much will the account be worth in 10 years. So I started with $3,000 in my investment account. The account is paying 3% interest compounded quarterly. And they're asking how much will be in the account after 10 years. So first of all, I have a compound interest and it is compounded quarterly. So that means the interest will get added to my account every quarter. And how many quarters are there in 1 year? There are 4 quarters. So compounded quarterly means my end is 4 because it's done 4 times a year. I started with $3,000, so my starting balance is $3,000, which is my principal is $3,000. My interest rate is 3%, so that will be R. R is 3%, which is 0.03. I invest the money in 10 years, so T is 10. And I'm looking for the amount in the account after 10 years, so I'm looking for A. So the interest is compounded quarterly. That means I need to use the compound interest formula. And my compound interest formula is A equals P times 1 plus R over N to the NT. So I'm replacing P with 3,000, R with 0.03, N with 4, and T with 10. So to evaluate this, I'll simplify this fraction first. I'll take 0.03 divided by 4. I get 0.0075. And also 4 times 10 is 40. A equals 3,000 times 1 plus 0.0075 raised to the 40. So 0.0075 is from 0.03 divided by 4. And 40 is from 4 times 10. Now from here, I'll take 1 plus 0.0075, which is 1.0075. A equals 3,000 times 1.0075 to the 40. Now, I can put this whole entire thing in the calculator, or you can just take 1.0075 raised to the 40 first, and then take that number times 3,000. 1.0075 raised to 40 equals, and then I take this number times 3,000. So I got A equals 4,045.04583701. The question does not give me any rounding instruction. However, I'm working in the amount of dollars, so I'm going to round it to 2 decimal places. This digit is 5, so I'm going to round up to 4,045.05. A is $4,045.05. This is how much I have in the account after 10 years. And this amount is including my principal and my interest. My principal was $3,000. I invest that in an account that pays 3% interest compounded quarterly. After 10 years, I have $4,045.05, which means my interest is $1,045.05. Next example, a certificate of deposit, or can also be called CD, is a savings instrument that many banks offer. It usually gives a higher interest rate, but you cannot assess your investment for a specified length of time. Suppose you deposit $5,000 in a CD paying 6% interest compounded monthly. How much will you have in the account after 20 years? I started with $5,000, so that is my principal. I put that in a CD that is paying 6% interest and compounded monthly. Compounded monthly means the interest will be added to my account every month. How many times is it in 1 year? There is 12 months a year, so N is 12. Your P is 5,000. Your R is 6%, which is 0.06. They're asking how much money will I have in the account after 20 years. So T is 20, and I'm looking for my A, which is the amount of money I have after 20 years. So this investment is paying 6% interest compounded monthly. So I'm going to use the compound interest formula. My compound interest formula is A equals P times 1 plus R over N raised to N times T. I will replace P with $5,000, R with 0.06, N with 12, and T with 20. A equals 5,000 times 1 plus 0.06 divided by 12 raised to 12 times 20. So I'll simplify, taking 0.06 divided by 12, I get 0.005, and then 12 times 20 is 240. So I have A equals 5,000 times 1 plus 0.005 raised to 240. So 0.005 is from 0.06 divided by 12. 240 is from 12 times 20. Now I take 1 plus 0.005, which is 1.005. A equals 5,000 times 1.005 raised to 240. And I'll put this in my calculator to get my answer. So first, I'll take 1.005 raised to 240 first. Enter. And then I'll take this number times 5,000. And this is my answer. A equals 16551.022379. The question does not give me any rounding instruction, but again, we're working in the amount of dollars, so we're going to round it to 2 decimal places. This digit is 2, so I'm going to round down to $16,551.02. So after 20 years, I have $16,551.02 in my account. This is including my principal and my interest. Next example, a 529 plan is a college savings plan in which a relative can invest money to pay for a child's later college tuition. and the account grows tax-free. If Lily wants to set up a 529 account for her new granddaughter, wants the account to grow to $40,000 over 18 years, and she believes the account will earn 6% compounded semi-annually. How much will Lily need to invest in the account now? Okay, so Lily wants to start the account for her new granddaughter. She wants to invest that for 18 years, and she wants to have $40,000 after 18 years. $40,000 is not the amount that she starts with. I don't know how much money that she is starting with right now, but she wants to have $40,000 after 18 years. So this $40,000 is the amount that she wants to see in the account after 18 years. So this is not principal. This is A, the amount of money in the account after 18 years. T is 18. Now, she believes that the account will earn 6% compounded semi-annually. So this is compounding, and it's compounding semi-annually. Semi-annually, how many times a year if it's compounding semi-annually? It's twice a year, right? So N is 2. How much will Lily need to invest in the account now? So the question is, how much does she need to put in the account right now if she wants to have $40,000 18 years later? How much in the account now? So they're asking for P. I want to know what P is. Where my A is 40,000, my T is 18, N is 2, and R is 6%, which is 0.06. I'm still using my compound interest formula, but instead of looking for A, I'm looking for P now because I don't know what P is. I know A is $40,000, R is 0.06, N is 2, and T is 18. So I'm going to substitute $40,000 in for A, substitute 0.06 in for R, replace N with 2, and replace T with 18. And I'm trying to solve for P here. Right, in order to solve for P, I'll just simplifying this parentheses first. I'll take 0.06 divided by 2 to get 0.03, and then 2 times 18, which is 36. I have 40,000 equals P times 1.03 raised to the 36. Now, I need to take 1.03 raised to the 36, 1.03 raised to 36. I get 2.8982783828. So 40,000 equals P times 2.8982783828. Notice, I'm not rounding my number here because this is not my answer yet. I only allow to round at the very last step. I'm not rounding in between my calculation. So that's why I carry all of the digits that I see in my calculator. Again, if you round it here, your answer will be a little off and you do not get the right answer. So I carry every digit I have here. So I have $40,000 equals P times 2.8982783828. To isolate P, I divide both sides by this number. So I divide this side by 2.8982783328, and also divide this side by 2.8982783328. So this number got canceled out. I get 40,000 divided by 2.8982783328 equals P. And to find P, I'll take 40,000 divided by this number. 40,000 divided by 2.8982783328 equals, and this is my answer, 13,801.2970023. So this is my answer here. Notice that I don't have any other calculation following this step. That means this is my last step already. That means I'm allowed to round this number. Again, do not round the number up here because you still have more calculations to go. Only round it in the very last step. Okay, so I don't have any rounding instruction up here, but because we're working in the amount of dollars, I'm going to round it to 2 decimal places, which is stop right here. This digit is 7, so I round up. I get 13,801.30. If Lily wants to have $40,000 after 18 years in the account that earns 6% compounded semi-annually, she needs to start the account with $13,801.30.